Hi, how you doing? Today we're going to look at the variance of a sum of two random variables. Let's start by looking at the rules of the expectation operator. We know that if we take the expected value of a sum of random variables, that is equal to the sum of the expectation of each random variable. In short, the expectation of a sum is the sum of the expectations. Now, is there a similar kind of rule for the variance? The variance of x plus y. Now, most likely, some of you are thinking that it's equal to the variance of x plus the variance of y. We're going to see whether this statement is true. First, recall the result, the definition of the variance of a random variable. Okay, by definition, the variance of a random variable, say w, is equal to the expected value of the squared of the random variable minus its mean. Now, if we since w is any random variable, if we let w equal to x plus y, so that variance of w is the same as variance of x plus y, we can also substitute wherever we see w, we can substitute for x plus y. So here it becomes x plus y, here it becomes x plus y. So this expression becomes, okay, so I've directly substituted wherever I see w, I've replaced it by x plus y. Expectation of w is the expectation of x plus y. Now the idea is that we want to get this expression so that we can break down it into the variance of x plus the variance of y. Look at this expected value of x plus y. We know from the expectation rules we can take the expectation through the bracket like this. So now if we substitute this back into equation 2, we like so, and we can group all the x's and all the y's together like so. Minus goes through the bracket, so all the signs in there change. That's a minus ex, which is here, minus and a plus, that's a minus, so we have a minus expected value of y, that is here. So I've used using these brackets here to show you that this here is a block, this here is a block. And when I expand out the brackets, I'm going to keep these blocks together because I've got to extract out the variance of x and the variance of y. So to show you what I'm doing then, let's call this block A, let's block B. Then we can write it like this, which is this, and we know that we can get the answer by multiplying A by A plus A by B plus B by A plus B by B. So we get this. Now simply replace the A and B's in terms of x's and y's. Okay, so I have this expression. So why I've just used A's and B's here in this red ink is just to show you how to multiply it out, and to also it's helpful to think like this when we have great big blocks like this, because if you were writing this out in full like this, it would be a very long expression. As usual, take the expectation through the brackets like this. Okay, now look at this expression. Does this look familiar? Yes, because it is the definition of the variance of x. This one, that is also familiar. That likewise, that's the variance of y. Now this thing here, 2, that's a constant, and the x's is a random variable. That's a constant, that's a random variable, that's a constant. So we've got a product here of a constant with things that are this whole block will be a random variable, that whole block is a random variable. This is a random variable because we have a random variable minus a constant. Well, it must be random because it's composed of a bit which is random. So using the rules, we can say that since it's a product of a constant and random variable, we can take the two out, like so. And now let's look at this bit here. Now this bit, this thing here is the formula, no, not the formula, is the expression for the covariance of x and y. So the variance of x plus y is equal to the variance of x plus variance of y plus 2 times this thing, the covariance of x and y. Going back to this original question, is the variance of x plus y equal to variance of x plus the variance of y? Well, we can see now, that the answer is no, it's false. Okay? It's false unless the covariance of x and y is 0. Okay, so let's bring the results together. In general, variance of x plus y is equal to the sum of the variances plus 2 times the covariance. But the variance of x plus y is equal to the sum of the variances only if the covariance is 0. And this is the case if x and y are uncorrelated, or if x and y are mutually independent. Mutually independent just means that x doesn't depend on y doesn't depend on x. Now, the introductory stats textbooks that I look at usually just present this result and say that x and y are independent. If x and y is independent, then this holds. But we note here that we don't require independence. It will also hold if x and y are uncorrelated. In fact, this mutual independence is a stronger condition than zero correlation. If x and y are independent, it means they are uncorrelated. But if x and y are uncorrelated, it doesn't mean they are independent. We'll discuss in another video more about zero correlation independence, but for now just know that this here is a general formula, and then this holds if there is zero correlation or if the two random variables are mutually independent. Okay, thanks there. For more material, visit us at statisticsmentor.com.